Hello, everyone. Welcome. My name is Daniel Moyer. I'm a sales support trainer here at Briggs and Stratton Energy Solutions. With me today is Nathan Hessen. Hello, Nathan.
Hi, Daniel. Good morning, good afternoon, good evening, depending on where you are around the world. Welcome, everyone.
Yeah, welcome. Thank you. So what we have today is we're going to be talking about energy storage systems in harsh environments. I think it's kind of appropriate being winter. And so we're going to look a little bit about what can happen to a battery, when a lithium ion battery specifically, when you charge it below certain temperatures, and how we mitigate that, how we prevent it from getting too cold. So this course is NABCEP accredited. We're going to be giving out some continuing education credits. Our email is going to pop up at the end of this talk. Go ahead and email us your full name, spell it out for us, and then we'll go ahead and issue you the credits after checking the logs. Couple events coming up, really exciting, is Distributech. This is next week, I believe. We're going to be out in Florida. Nathan, you're going to be at this one, right?
Yeah, I'm looking forward to it. We're going to have some of our latest products there at Distributech in Orlando. So if you're coming to Orlando, please let us know.
Yeah, and one of the ones he's hinting at is that 6.6 battery that you see there. That's actually 6.6 kilowatt hours each one of those stacks. So you're looking at a little bit less than 20 kilowatt hours. We got another slide coming up a little bit later to talk a little bit more about that. Another really exciting one of the kind of highlights of my year is the NABCEP Continuing Education Conference. This is about Raleigh coming up later this month. I'm going to be giving a talk about off-grid living with simplified batteries, talking about how we can use these batteries in off-grid situations. We're one of the few companies that still warranties not only our batteries, but we also make generators that work and warranted for off-grid use. Nathan, what are you going to be talking about?
I'm going to be talking about the SolarArc 15K and how it pairs with our new battery. All right, I'll be talking about that battery stack that you just showed and how it's designed to work perfectly with SolarArc 15K whole home installs. Additionally, if you are coming to NABCEP, we would really like to know that. We'll bring out some free swag. Daniel, you want to give them some details?
Yeah, so how about this, everyone? Let's say you come there, we will give you a free sweater. Considering this is kind of harsh environments, we're going to talk a little bit about hot weather and altitude, but really it's cold weather. And cold weather considerations for lithium ion batteries is becoming a bigger and bigger topic. We're seeing lithium ion energy storage systems being installed in parts of the country that historically haven't seen them, in the Minnesotas, the Maines, and cold weather is a big consideration. So if you're coming to NABCEP, let us know. Email us. Our email will be at the end of the presentation. We will have a sweater for you, and we will also make sure we set aside some time to personally talk to you. On the screen right now is a QR code that allows you to register for NABCEP. And Sue, who's one of the founders of NABCEP, her email is up there as well if you have any questions.
We just want to highlight that that's probably our favorite conference of the year, right, Daniel? It's all
Agreed.
about education. It's all about learning about the latest developments in the field. And we really encourage you to get to NABCEP if you can. And that's why we'd like to kind of entice you there by bringing you a free hoodie and free sweater.
Yeah.
So email us. Let us know you're going to be there.
Yeah, and really that's kind of going to be our launch. We're going to be having, and I don't want to give away too much, but we're going to be having a launch party. So you email us, you let us know. I'll make sure you get an invitation to that launch party. What are we launching? The 6.6 battery. Really excited about this. It's a stacking architecture where each one of those modules is 6.6 kilowatt hours. There's no communication wires to run, no power wires to run. Why? Because they're all stacking and connecting together. It's going to really make the ease of installation a lot quicker. We're still, of course, going to be producing our legacy batteries that are still a workhorse of the industry. But this is a really exciting advancement. If you scan the QR code that's on your screen right now, you can get on a mailing list for upcoming promotions, releases. Keep up to date on this product that's coming out as well.
We'll be shipping out that battery mid-second quarter, right? So it's a really exciting battery. As Daniel said, no wiring there. That battery stack that's shown there was assembled in 3 minutes by one of our technicians. Yes, you still have to run those home runs, right? You can run those home runs off that battery, up to 1C output on this thing. So we're really excited to be releasing those specs. That'll be coming soon. And if you want to have that information about those specs, QR code in the bottom right corner.
Yeah. Yeah.
We got a lot
Appreciate
of
it.
content for you today, so we better go quickly. But
Yeah.
highlighting one of the facts here, we are a California recognized battery manufacturer. We are manufacturing at our factory down in Oxnard, California, and you can get an additional discount by applying for the CPUC credit if you're doing an installation in California. So do look into that, especially you California installers.
Yeah, exactly. The self-generation incentive program, the SGIP program, was the bucket for the money was refilled into that program. So if you have customers that are on well pumps, if you have customers that are on medical devices, there's a lot of money out there, opportunity for them, not only in addition to some of the adders that are available because we are recognized as a California battery manufacturer. So definitely take a look at that. One, Nathan, I wanted to pull up this kind of map this morning. Now, as somebody who's a geographer, this map projection isn't the best here. Texas is a lot larger if we had a more accurate projection here. But what this is showing us is it's cold. This is tonight's projected nighttime lows. And I'm looking up there in Maine. If anybody's from Maine, New Hampshire, Vermont, put something in the Q&A chat. And I didn't mention that earlier, is we want your questions. We appreciate your feedback and your comments during this talk. Put them into the Q&A chat and let us know you're there. But there's a lot of parts of the country that get cold in the winter, right? And it's also important to recognize that just because you see some parts of the country that are cold, 27, 28 degrees, doesn't mean that that's the temperature that's going to be inside the battery. That's not the temperature that's going to be inside of a battery cabinet. So we want to understand that there's going to be a temperature gradient between ambient temperature and maybe what's inside of a battery cabinet. So we're going to talk about the temperature ranges that these lithium-ion batteries can operate at, but don't confuse that just because ambient is one temperature that the battery is going to be another one. Understand that there's going to be internal resistance in the battery during charge and discharge cycles that are going to warm the battery up. Understand that there's other parts of the system like a Solar 15K that may be in that same enclosure that's going to be generating heat, that's going to keep the system a little bit warmer than what you see in ambient. So this is definitely, I didn't realize it got to 35 degrees down in Florida. So have fun there at Distributech there next week, Nathan.
Well, typically those are only middle of the night temperatures,
Yeah,
and I lived in Florida for many years, and it very rarely got down to those 30s. So Daniel, let's jump into some of the basics here. We're looking at using these cylindrical cells in our batteries, right? These are what we use in our Amplify, our Phi, our 4.9 batteries. We use these cylindrical cells, so that's known as the form factor. And what you're looking at there is a cross section of what that roll, that's called a jelly roll, what's rolled up. And that's how that energy is stored in a lithium ion battery. So in our case, so the batteries themselves typically vary in what the positive side of the battery is. Most batteries are using graphite anodes. And the lithium is stored there in a charged battery. You have lots of lithium between the layers of graphite. So you might know that as kind of like a honeycomb structure on a microscopic scale. So a charged battery, the lithium ions are located inside the graphite layer. And in a discharged battery, those ions migrate over, the lithium ions migrate over to the metal oxide side. In our case, we're using the safest chemistry for that metal oxide side, the cathode, the positive side of the battery. We're using lithium iron phosphate. So that's iron phosphate. It's a chemical that occurs within our bodies, right? That's our cathode. And so the lithium moves to that side. It prefers to be there. And so the energy in your battery is that the driving force of that energy is the fact that the lithium prefers, it's more stable when it moves into the metal oxide side. So to charge up a battery, we're looking at using an external charger to pump those electrons around to the graphite side. Those electrons are not allowed to move between the positive and negative side inside the battery. There's a separator layer there. You can think of it almost like an insulator in between the two cells of the battery. Now, throughout that material, throughout the metal oxide and the cathode side and the separator layer is an organic electrolyte solution. This is typically a hexafluoro sulfate. or sorry, phosphate. That's electrolyte, and there are ways that we can enhance this electrolyte. And
Yeah,
we've
and that
seen that
brings
in
up a
some of our
question,
newer
Nathan.
batteries. Yeah,
Yeah, so
sure.
so I understand that, our legacy batteries, the Phi and the amplified battery, have a certain temperature window, but I also understand that our new 6.6 battery that's coming out can operate in a wider temperature range. Additionally, it can also discharge quicker as opposed to a 2C, which is relatively still very quick to discharge a battery in 2 hours. The new 6.6 simplified battery can discharge at a 1C or within 1 hour. So what kind of attributes are in the cell structure that allows our 6.6 battery to operate at a wider temperature window and at a faster discharge rate?
Yes, you have a lot of let's call them levers or dials that you can turn when you're manufacturing batteries, right? So one of the things that you could do is make that separator layer thinner. You can decrease the separation distance between the cathode and the anode. You can also improve the salt, right? So that organic electrolyte salt solution that is there has a viscosity, and at colder temperatures you have more viscosity, and it makes it harder for the lithium ions to move. So by improving that salt with additives, you can put different additives in there. You can enhance the mobility at lower temperatures. And so Simplify is constantly looking for improvements in battery technology and implementing them once they're tested to be both safe, right, and durable. We want long lasting. So not only you can take any battery and discharge it really quickly, right? Is that battery going to hold up? So even at a 1C rate, we're looking at very high life cycles for that new 6.6 battery, stackable battery that's coming out. And so some of the improvements are what is inside that electrolyte.
Yeah, thank you, Nathan. I thought it was important that we spend a little time here explaining kind of the science behind it and why when you're charging a battery, these lithium ion batteries, they're really expected to be the energy storage of choice going forward, not only for our home energy storage, but also for our vehicles. Why? Because it's safe, it has a long cycle life, and it's very energy dense. And as Nathan mentioned, when the organic electrolyte or inorganic electrolyte becomes cold, it allows it prevents the ions from migrating and causes that sluggish kind of movement. Now, it's not necessarily the organic electrolyte or inorganic electrolyte that's preventing them from moving slowly. It's the battery management system, or the ability for the system to slow itself down so you're not going to damage the battery. And how can you get it damaged, right? If you push them too fast. I kind of like this idea that they're getting crowded up and they're eventually going to kind of build up on the surface. So as Nathan said, there's different ways that we can do to improve this. And I really liked this diagram here. It's kind of explaining what Nathan had mentioned, is if you're pushing those lithium ions too quickly, they kind of build up, right? They're not able to intercalate into the anode, and they can cause dendrites to grow. Nathan, is there anything you wanted to expand on this?
No, I think that's a good explanation, Daniel. I think what we are doing here when we're charging a battery up, as seen on the left diagram on the screen there, is you're pumping those electrons to the anode side. That's the graphite side. And you're moving those electrons to that graphite side, and the lithium is attracted and moves to the right as well to join those. On the right diagram on the screen, it's showing as you charge up that battery, if you're doing it in very cold weather, if you're doing it under too cold conditions, under many, many cycles, you can get the growth of solid lithium deposits. And those solid lithium deposits, unfortunately, don't deposit as just a solid, smooth film, right? They grow into branches and chains. And with thousands of cycles, you can eventually, even hundreds of cycles, if you do this at really low temperatures constantly, you can puncture. You can have growth of lithium that punctures that separator layer and eventually even short out some of the cells in your batteries. So that's why it's so important to maintain appropriate charging temperatures for your batteries.
Yeah, and even if it doesn't penetrate the separator layer, those lithium ions are no longer able to be used in the charge and discharge process. So we're losing capacity in the battery.
That's exactly right. You have less lithium ions that are there. Now, there's been a lot of talk about solid state batteries, and it's worth mentioning here. Simplify tries to be in the very kind of front of introducing tested technology. And solid state electrolytes are essentially plastics, right? And now solid state electrolytes were discovered by Faraday over 100 years ago, Michael Faraday. But these electrolytes are not quite there yet, right? These solid state electrolytes are not quite there yet. And what it typically means is you're going to have a plastic material, a separator layer that is made of polymer. And that layer is able to conduct the lithium ions while still blocking the electrons. And that technology, you know, I know Toyota's been touting it. It's not quite ready for the market yet, but that could eventually allow you to get rid of the graphite layer that houses the lithium. And in doing so, you could greatly decrease the weight of the battery. But even Toyota hasn't gotten that to the point. I constantly get asked, well, what, you know, aren't we going to have solid state electrolytes soon? Maybe, right? Again, it needs to be a proven technology. We want our batteries to last for 10,000 cycles. We want our batteries to last our customers for that 15-year warranty that we're giving. So let's keep going here.
Yeah, so what we were talking about really is charging lithium ion batteries in too cold of temperatures. Charging them. What can happen? You can damage the battery. You can reduce the capacity of the battery. But what happens when we discharge a battery? What are some of the problems or complications that are incurred when we discharge a battery under cold temperatures? And I'll let Nathan kind of run us through this slide here. Is that, and I'll kind of summarize it and spoil your whole talk here, Nathan, is we can have difficulty understanding the state of charge of a battery when it gets cold. Nathan,
Yes.
please elaborate on that.
Yeah, now this graph, it could be a little bit misleading here. And so I don't want you to think that a battery that you know, if the ambient temperature is 10 degrees Celsius, you'll see this drop off in performance. What we're looking at is battery cells which were in an oil bath where we fixed their temperature at cold temperatures, right? So what you're looking at is you control the temperature of the cell. Now with a real cell, if you look on the left side of your screen, if you discharge a battery, right, you can see that there's some internal resistance. And that internal resistance is a function of the viscosity of the electrolyte. So at really cold temperatures, you're going to have increased internal resistance to the cells. And so if you're discharging at really cold temperatures, what this means is you can have a fairly big drop in your voltage compared to your resting voltage. All right, so let's break that down quickly. All right, so resting voltage is shown on the curve. Resting voltage is when your battery's neither in a charge cycle or a discharge cycle. A fully charged lithium LFP cell is typically going to be around 53 to 54 volts fully charged. Okay, and so somewhere around that 54 volt mark would be fully charged, but the resting voltage is what I'm talking about will be 54. Now, if I start a discharge cycle, these are all C/2 discharge cycles. Okay, so that means I'm discharging this cell about as fast as I can. Now, what would normally happen if you're discharging a battery quickly is the temperature of those cells would start to warm up.
But you're in an oil bath.
I'm in an oil bath with these. I've got these cells in an oil bath, right? Keeping them nice and cold just to see what happens. So we're showing you this because if you're discharging your batteries in very cold temperatures, you'll notice a significant voltage drop as soon as you start a discharge. And that voltage drop is proportional to your load. So the bigger your load, the bigger the current you draw out of the battery, the more voltage drop you'll have. So in very cold days, if you all of a sudden start a fast discharge of your batteries by putting a really high load on them, you can hit LBCO much earlier on your inverter. So keep this in mind.
Yeah, so it might hit low battery cutout voltage, even though the battery has a lot of juice left in it.
Exactly. There could still be plenty of lithium ions inside the graphite layer, right? That's a charged battery when the lithium is over there inside the graphite. But if it's cold enough, there'll be enough of a voltage drop across the inside of the battery, across the internal resistance, that you'll hit LBCO a little bit too early. So now we can actually use this, right? So let's go ahead and move on from this. This is not a talk all about chemistry, but we're trying to give you the basics and tell you how we can use this. So we've got a couple of different types of our 3.8 batteries. It's a really popular battery on the market. These 5 batteries, they've been out for years, right? And we have many of these batteries, thousands and thousands. We sell many of these batteries every month that are on the market. Now, these batteries, if you keep the ambient temperature above 32 degrees Fahrenheit, these batteries can charge no problem. But that charging window, you should not be charging these 5 batteries below freezing, right? You should not charge them below 32 degrees, below 0 Celsius. If you do that, you greatly increase the risk of dendrite formations. You void your warranty, right? You increase the risk of dendrite formations and damage to the battery. So you can avoid this. Yeah, and we're going to talk about some solutions we have that can help you avoid this. And certainly we can do temperature monitoring, etc. The Amplify battery, you can actually charge that below 32, below 0 Celsius. You can go all the way down to negative 20 degrees Celsius and charge very slowly. Now, the point we're making here is that if we actually start charging this battery slowly, that internal resistance produces heat inside the cells, which warm up those cells. And
as long as it's not in an oil bath.
As long as it's not in an oil bath controlling temperature, exactly. So if we start off at, let's say, negative 15 degrees Celsius, these batteries are going to be limited to only charging at about 3% of their normal rate, okay? But that charging process introduces heat, right? Because that increased internal resistance at this low temperature. So that starts to heat up the battery. And once you get to negative 10 degrees Celsius, you'll charge at about 10% of the rate. And so that charging rate keeps increasing as those cells warm up. And so when those cells warm up to 7 degrees Celsius, right, then you're charging at that, then you begin charging at that full rate again. So if you've got a very cold day, and the sun is out early in the morning, it's 7 a.m., it has been a really cold night, and your batteries are in a cold location, it's possible that you're only seeing reduced charging rates on your Amplify batteries or even your 4.9 batteries, right? Because they're cold and they're reducing that charging rate to protect them. Now, there are some fault conditions here. If you are below negative 20 degrees Celsius, you won't charge at all. Okay, so if you want to try to keep your batteries in an environment that maintains an ambient temperature above 0 C, that way you'll get the most output out of your system. There's also some storage considerations, right? So we have some recommendations. People often buy these systems and then waiting for their permits or other reasons, right, might not install them in a quick time frame. It might sit in their garage for a few months.
Maybe another example would be a summer cabin, right? Up there in Maine where the batteries are sitting over winter. Come in springtime and you know that your batteries are going to be able to provide that energy for the off-grid cabin. Additionally, it has a very low self-discharge rate, maybe 1%
which is amazing,
as well.
Yeah, one of the nice things, that 1% a month, these lithium batteries, as long as you have them turned off, right, really don't self-discharge very quickly, and that allows you pretty long storage times. Now, we do recommend that if you're in extreme cold conditions, you charge them once in 3 months. If it's in warmer conditions, once every 6 months. But really, self-discharge is quite slow in these batteries, and you can leave them for significantly long periods of time without any damage to the battery.
So, exactly, yeah, keep them there. So to summarize a little bit what Nathan had said, we offer, our 5 3.8 kilowatt hour batteries and an Amplify 3.8 kilowatt hours. What you're seeing on the screen right now is the Phi battery does not have closed loop communications. That doesn't mean it's anything less than the Amplify. It still has the very the safe chemistry, the safe form factor, and it's the ability to work with other pieces of equipment that don't have the ability to talk to it. So we see this leveraged a lot in older kind of lead acid battery replacements and off-grid systems where you might have an old Outback, an old Schneider, old Morningstar, old SMA. So this battery is definitely applicable in cold weather conditions. Just keep in mind that it doesn't have the feature that the Amplify has, which is its ability to know its internal temperature, and then, as Nathan explained, transmit that temperature and the appropriate charge rate to a piece of equipment to slow down that charge rate.
Yeah, so Daniel, no, I would argue here, that Phi battery is well suited for large systems, right? For large systems, you're probably going to have some external controls. You're going to be keeping track of the temperature. And so the difference here is that 5 battery, each individual battery module doesn't have all of those, the closed loop communications built into it. So there's a cost savings there.
Yeah.
Now with the amplified battery, we have that more sophisticated computer inside every one of these. The battery management system in this amplified battery, designed here in Oxnard, California, very well made BMS. It's a high-end BMS, and so for smaller systems where you want every one of your batteries to have that closed-loop communications, be able to provide detailed information out, right, telling you about how the battery is functioning, what the temperature is, what the charge rate should be, what the state of charge is, etc. Allow it to talk to the inverter, control the inverter through CAN bus. Right, this amplified battery can do that. Same with the 4.9 battery that I think you're about to show, right?
Yeah, exactly. And also the new 6.6 as well. So we kind of talked a little bit about temperature. We're going to talk a little bit about weather protection. So the Phi and Amplify 3.8 kilowatt hour batteries are indoor rated batteries only. The 4.98 battery, which I don't show here on the screen, I think I have that coming up, Nathan, it is outdoor rated. Additionally, so is our new 6.6 Simplify battery. If you're going to be leveraging the Phi or Amplify battery, we sell these battery cabinets. We call them the Boss 12 or the Boss 6 cabinet, and you can put 6 or 12 batteries in these battery cabinets. And we're going to show you a little bit later coming up. There's an ability to add heating pads to these enclosures as well.
Yeah, one of the reasons we're maybe not showing the 4.9s and the 6.6s is, in cold environments, right, you're more likely going to install these batteries indoors. And you don't need to put these inside one of these cabinets, right? These batteries, if you've got them indoors, if you've got them protected from the elements, these batteries are just not waterproof, right? The difference is that 4.9 battery is waterproofed. It's got a rain cover on it. It's a NEMA 3R enclosure. The same with our 6.6. But these battery cabinets can also offer you some just increased internal temperature relative to the ambient temperature, right? So if I've got an enclosure, the inside of the enclosure is going to be a little warmer than the room temperature that's there.
Yeah, and how do we lose heat, right, Nathan? It's conduction,
convection,
and radiation, right?
Yep.
So conduction, we'll probably want to insulate put some rubber pads or maybe some pink foam on the sides of the enclosure. Convection, right? Maybe we don't want that fan to turn on when it's cold out and start blowing cold air in there. And radiation, right? Nighttime radiation loss. So we're able to maybe put some sort of structure over there, or kind of put the Boss 12 cabinet underneath an overhang or something, prevent that
so
kind of radiation.
People typically use that reflective foam for radiation, right? So you'll use a foam with that aluminum coating on the surface of that. Radiation becomes a much more common source of heat loss on very high temperatures. The Boltzmann law, it goes up as temperature to the 4th power, right? So when you get to really high temperatures, that's when you're getting a lot of transfer there. So the main one that you mentioned, I appreciate you mentioning them, is that conduction, right? Conduction from the battery cases out through the shelves, right? So if you're in a cold environment and want to keep your batteries a little bit warmer, slip a piece of foam underneath those batteries. It doesn't have to be very thick to offer a significant amount of resistance for that heat moving out of the battery.
Additionally, we have access cabinet where we take out 6 batteries out of the Boss 12 and put a Solar or our Simplify 6 kilowatt inverter in that as well. So I think we already covered a little bit of this. Again, cold temperatures can result in a loss of capacity, reduction of cycle life from that dendrite growth as well. So again, and we've already kind of discussed this a little bit, is that our Amplify and our Simplify batteries are able to have a battery management system that knows its internal temperature and that can then transmit the appropriate charge rates, kind of shown on that chart that you see to the right, to a piece of equipment, whereas the Phi battery does not automatically reduce that as well. We talked just a few minutes ago about having insulation that would curtail the heat loss through conduction as well. And we also talked a little bit earlier about understanding that having other parts and pieces like that inverter, like other charge controllers inside of a cabinet, will generate heat, and that not necessarily the ambient temperature is what you're going to see in a battery cabinet, not necessarily what you're going to see internally in between the cell pack inside of a battery as well.
Daniel,
Yeah.
Bill mentions here, so the Amplify battery communicates with all the information that I mentioned here, that we've mentioned, to the inverter and charge controller to modify charging. Does that mean that the installer/user can also see this information? Yeah, and I can answer that, or you
Yeah.
can.
No, go ahead, Nathan.
Okay, sure. So Solar plots a number of this information that the Amplify sends out. It will share some of this information with you, but we can capture even more of that with the Briggs and Stratton gateway. And we're not currently selling a software package for standalone battery systems that go with other inverters. However, that is on the roadmap and coming up in the second quarter here. So I don't have an exact date for when that's going to be released. But yes, you can see a lot more information with a Briggs and Stratton gateway. And we'll be offering an option just for battery installs when paired with other people's equipment.
Yeah. Thank you.
Great question, Bill, and thanks for asking. And we're constantly looking to give more and more information to the homeowner and the installer. So more information is being added with this battery. It definitely sends it out. It's just depending on what equipment you're using, you have more or less access to it.
Yeah. So we talked a little bit about systems that can operate in cold temperatures using the communication. At some point, though, there may be a need to have external heating pads, essentially, for our batteries. And we do offer that for the Phi and the Amplify 3.8 kilowatt hour batteries. What we do is, it's a special order from the factory. What we do is we embed a thermostatic sensor. That's what you can see, this little gray plug that you see kind of in the middle. And what's important about that is we're embedding this thermostatic sensor in the cell pack itself. So we're actually reading what the cell temperature is, not, you know, some sort of ambient kind of temperature sensor that's, you know, sitting on the side of the battery out externally. Then what we can do is we have the heating pads themselves. You can see that in the top right photo there, that are kind of adhered to the back of the bottom of the battery. And by doing it in that manner, what we're doing is when the heating pads do come on, they propagate the heat through the battery cell packs very evenly, and we get an even distribution of heat when we heat up the battery as well. These heating pads are only about 75 watts, but it's important to understand that they cycle on and off, and they're not on, say, consistently. I want to point out in the battery, this is what we're looking at, a Boss 12 cabinet here. You can see these kind of unistrut channels, I guess is what I'll call it, here on the right-hand side. And now what we're looking at on this slide is a close-up of what the controls look like. So I've already showed you the embedded thermostatic sensor. I've already showed you what the heating pad looks like. What I'm showing you now is the AC input. So these operate on AC. They operate on the inverter's output. So we need to take into account the load that's going to be imposed on the system from these heating pad solutions. But how it works is we take in just, it's just 120. We take in a line L1 on this, and then we're able to feed that AC power into these, essentially these thermostats here. We feed that temperature sensor into T1 and T2. We feed the heating pad itself on ports 11 and 14. And then those little red circles are essentially the temperature, and probably also the temperature differential that the heating pads are going to cycle on and off at. This is a special order. Go ahead, Nathan.
That's a good point, Daniel. And yeah, this is a special order item, but I do, want to let everybody know that this comes pre-installed. You don't have to do this yourself. So if you do want this solution, if you're in a really cold place and want this solution, we can build this into our Boss cabinets and Access cabinets. So it comes pre-assembled. You won't have to do this. But we just do want to show you this. And to Daniel's point, 75-watt heating system. This is on the batteries, but it's only coming on when those batteries need it, when they're in that low temperature window where charging can't occur. I got a couple of questions I want to give you, Daniel.
Yeah.
Bill says, what state of charge do your 3.8 batteries ship at? So what state of charge are we shipping at? And I believe that there used to be regulations around us not being allowed to ship it greater than, was it 30% state of charge?
Yeah, usually it was around 30%.
And now that's changed. And I believe our Amplify batteries ship at a 90% state of charge. And I think that the Phi batteries are still required to ship at a lower state of charge.
Regardless, though, I think, yeah, you're right on with that. Regardless, I would always recommend that we get one full charge cycle, one full bulk, get it into the absorbent float, and then make sure you get one full good charge cycle on the batteries
Before
before
you
you
allow
turn on
discharge.
any loads, no
Yeah, and
matter what.
that's
I
in
think
our
that's best
manual.
practice.
Yes, that is in our manuals. You do need to fully charge these batteries before applying loads to the system. So in that commissioning, that's your first step, is kind of getting to that full state of charge. Jonathan says, if working with an older off-grid system, like a Magnum inverter, for example, and we've worked with plenty of these Magnum examples, would you recommend the Phi battery due to its lack of closed loop communications? So it's a good question, Daniel.
Yes, absolutely.
Absolutely. Yeah.
Yeah.
In fact, we sell a system with Magnum inverters that uses Phi batteries.
And if you
Daniel,
don't
what's it
buy it,
called?
we also publish integration guides that tell you how to program that Magnum inverter
Yep.
in such a way that it treats our batteries the way they want to be treated, such as the float, the bulk, the absorb, disable, equalize, and the max charge and discharge rates as well.
Yeah, and I'm a big fan. I really like those Phi batteries, and we're using the same premium cells in those Phi battery packs that we use in the Amplify battery packs.
Yeah, that's what I was trying to articulate earlier, is that there's no difference between the two, except for the battery management system isn't communication capable. And if a Magnum can't listen to it, why buy something more expensive than you need?
Yes.
But that being said, if you don't happen to leverage it, there is other external temperature monitoring capabilities that are available from third-party devices. Such as example here, we're showing this, the Victron, right? So you have a Victron charge controller, and if you were able to leverage this Victron BMV712 smart meter, well, this can, again, alter the charge rate of the batteries to prevent damage to the batteries. It's not quite as nice, right? Because the temperature sensor is not embedded inside the cell pack, but you could still kind of get there a little close. Maybe let's take that temperature sensor and sandwich them between two batteries, so we're getting as close as we can to reading internal temperature of the batteries as well. Hot temperatures can definitely affect the life of the batteries. We do have a great example here. It looks like Nevada to me. But Nathan, what can happen to the internal chemistry of a lithium-ion battery when it gets too hot?
Well, remember that when you are charging and discharging batteries, there's a small amount of inefficiency, right? And when we speak about inefficiency electrically, we mean the creation of heat, right? So if you are charging a battery when it's too hot, right, you can overheat the battery. And overheating the battery, especially when we get to very high temperatures. Now, keep in mind, Amplify battery can discharge up to 70 degrees Celsius. It's over 150 Fahrenheit, right? I think it's around 150 Fahrenheit. It's very high temperature. And the Phi battery is slightly less. The discharge rate is still pretty high. I believe it's 60 degrees Celsius. That was on one of our previous slides. The charging window is a little bit reduced. The Phi batteries there will charge up to 120 degrees Fahrenheit. But if you get too hot, remember that's an organic electrolyte, and that organic electrolyte can create vapor pressure. And that vapor pressure between the layers of the cells can eventually cause delamination if you're doing this at too high of a temperature. So that's why we have a restriction on the upper temperature window as well. And the Amplify battery, if you get above that temperature window, it'll warn you. And if you get all the way above 70, at 71 degrees Celsius, the Amplify battery will actually it will turn off output to protect the cells.
Humidity is definitely a concern. I'm pretty close to the Pacific Ocean. I'm up here in Arcata, California, in Humboldt County, and I know you're down in San Luis Obispo County, pretty close to the ocean as well. When we're thinking about these batteries, and maybe confirm what I'm thinking here, Nathan, is it's not necessarily humidity, but it's maybe the salt that's contained in the warm, moist air that's going to cause a corrosion and rust.
Yeah. So I want to take just a second to talk about that a little bit. I have Daniel, my older Jaguar, right? And I had a pristine paint job on this thing. And, down in Arroyo Grande, 2 miles from the coast, it didn't take too long before I got delamination of the paint there. That clear coat started coming up. And that was kind of my introduction to the salt in the marine air when you're close to the coast. So if you are doing installs in the Gulf or Puerto Rico or Hawaii or close to the Pacific Ocean, like Daniel and I are close to the Atlantic, you have to pay attention to condensation that occurs on surfaces at nighttime, right? You want to have those windows closed at nighttime where your batteries are installed so that you're not getting that fog that's coming in with that salt there. I see an example here with a pool. There's chlorine in that pool, and if you have your batteries installed around that pool, you could get saltwater condensation around them. So there are different things that people can do. Some people even put silica gel packs. Silica gel packs that are come in shipping.
Do not eat.
Yeah, the do not eat packs, right? I mean, those are hydrates. Those are designed to absorb moisture out of the air. So some of the Powerwall installs, in fact, will require those and require you to change those out every 2 years. You can actually just heat those up, put them in an oven for 10 minutes, and they'll regenerate. They'll get rid of that water vapor. But yes, keeping salt water away from batteries and electrical installs is a very good idea. So I appreciate you mentioning that, Daniel.
Yeah, and then additionally, just water in general. Keep in mind that our Phi and Amplify batteries are indoor rated, and the Simplify and the new 6.6 battery are outdoor rated for water in general as well.
Exactly. And I would point out, when you are doing those installs near the marine environments, please do those in a location where that fog cannot get to that install.
Yeah, and so that brings us to one of the other factors is altitude. And and we recognize, and I forget from my geography class, that every 100 or every 1,000 feet you go up in altitude, the temperature drops. So when we're talking about high altitude locations, cold weather is definitely going to be a concern, but also the pressure, right? There's less atmosphere pushing down on us when we go up in altitude. So that can cause problems with not only the cells, but perhaps also other parts and pieces of the system, such as the inverter. So we do have specs on that, and most of the manufacturers do list that. One thing is, I'm thinking about the physical structure of a cell, Nathan, and a cylindrical cell. I mean, it's a cylinder, right? So a cylinder has a lot of inherent strength in that structure, whereas maybe a prismatic or a pouch cell doesn't have that rigid or kind of the ability to withstand pressure changes as well. Any thoughts on this, Nathan?
Well, we have, for our 4.9 batteries, our 3.8 batteries, the Phi, the Amplify, these batteries have no altitude limitations on them. So these batteries, we don't have any inherent altitude limitation. We just recognize that low temperatures can be an issue. These cells, currently typically have can handle pressures on the order of reduced pressures on the order of 10 times reduction of an atmosphere, so 1/10 of an atmosphere. So it's not really a pressure thing. They have a vent at the top that will open up if the internal pressure becomes too high, about 10 times the atmospheric pressure. That vent would open up. And so that's what happens in an off-gassing event. So if you took one of these battery cells and you threw it into a fire, that cell would eventually rupture, and the vent at the very top is there to prevent overpressure causing an explosion. But we don't have any limitations in terms of altitude. Just keep in mind that high altitude locations are typically coming with low temperatures, and low temperature protection is important.
One thing I've always been really excited about is these new RVs. People don't go out and buy, maybe people still go out and buy RVs, but in addition to Nathan's Jaguar, he also has a Sprinter van. And I've seen that. And a lot of times people are taking these Sprinter vans and converting them to these kind of adventure RVs or overlanding. And a lot of times they have very sophisticated, very expensive off-grid energy systems. And Victron makes a lot of great products. Our Phi battery is a perfect match for a Victron system. And one thing,
those Phi batteries come in 24-volt options too, Daniel.
Right? Yeah, that's right. Yeah, good point. Is that and what Nathan is mentioning is our Amplify battery is 48-volt only. Our Phi battery is 24 or 48-volt batteries, and we additionally do have some 12-volt ones available as well. You might see that comment in here. What we're looking at is this great airstream, and when we're thinking about, our batteries aren't necessarily approved for certain vibrations, standards. Well, that's not true. We do have one coming up for our UN listing, but here, one thing I want to mention is our batteries have been subjected to some very rigorous and extreme environments, and we've really seen the longevity and the batteries hold up. So when we're thinking about a battery inside of an RV, think about where you're going to place it, and how we're going to insulate it. Maybe again, put some padding underneath to insulate it from some vibrations.
So Daniel, that's a good point, and I appreciate you mentioning my Sprinter because I'm actually looking forward to building that out with some Amplify batteries here in the next few months. So, but yeah, it's a good point. There are different standards for batteries, right? And there's a little bit of a gray area, right? If a battery is being used while mobile versus a battery is just being transported in a mobile device. For instance, like a car battery has different vibration standards that it has to meet compared to a battery that's housed within a car, right? And so for an example, food trucks, right? Food trucks you're not using the battery while you're driving, you're just transporting the battery in that vehicle.
Yeah, or like an RV, right? The RV is going to be parked when you're
same thing. You're going to be parked when you're using that battery. It's not mobile power that you have. It's just transported power. And so I like your idea of just putting in some vibration dampening in there, and that's exactly what I'm going to do when I build mine out with the Amplify batteries. Is that I'm going to put some foam board down just to reduce the vibrations on the batteries.
Yeah, I recognize we're kind of coming up on the end of our time. Thank you everyone for being here. Keep your questions and comments coming. What we're going to show you is just a couple of examples of what it looks like in real life. These are some of our older batteries here, but it's a great picture of what somebody's done in an off-grid system up in Montana. There's a Schneider system there. And what we have is a battery bank of 6 of our 5 batteries. And they're enclosed in their kind of home-built battery box. And you can see some of that foam that you're seeing there it's insulating the batteries. You know, it's cold out there. You can see that bear right there. Additionally, what I want to point out here is that they've taken conductors of the same gauge and the same length and wired these batteries together to a common terminal block or central location.
Combiner, yeah.
And then from there, you can see just barely in the picture is a couple of larger conductors that are headed up to that Schneider equipment here. A nice pole mount system as well.
I like how this system, you know, I mean, I know this is a custom built system, but I like how you can take the lid off of it in the summertime, right? And, you know, those Schneider inverters are kind of bomb-proof inverters. I really like those XW Pros as well. So yeah, this is a nice looking install.
Here's another great one. Nathan, you want to talk a little bit about what we're seeing here?
Yeah, it looks like we've got some 2 parallel Solarc 12Ks there in a large number of our 5 batteries as well. This is this install also is in Alaska, and I'm sure this is in a temperature controlled room. And if you look in the bottom right, you've got a heater in there as well.
I see a gas, probably a propane heater there. And these pole mounts look great. Look how steep they're tilted up to capture some of that northern latitude sun as well. I really like the wiring troughs. I think the gutters looked really great here. And again, we have conductors that are leading to a common terminal block or point that are then kind of leading off into the Solarcs as well. And that's what's kind of great about the 6.6 is that the terminal blocks and the combining of the batteries are actually done in the stacking method itself.
Yeah, I would like to point out, you know, they used individual mounts, wall mounts for those batteries.
Yeah,
typically in large systems, right? You know, it's a less work to put batteries together on large shelves like this. So these are I believe there's 80 batteries on the left install. There are 90 batteries on that right install. The one on the left is another install. This is Wolf Solar Electric sent us this one just a few months ago. You've got, I believe, 8 12Ks paralleled there. And then the install on the right, we're looking at, you can't see all of them, but there are 7 15Ks there, and then 90 of the 3.8 batteries. And this is, you know, for large systems, that 5 battery is a great battery. And it goes very nicely with that Solar.
Yep,
yeah, to scale up.
Imagine the heat that's being produced in that room, especially during the day with the charge controllers. There's some inefficiencies, and we're generating a lot of heat, and the thermal mass of those batteries is huge, right? Even that metal racking that I'm seeing, there's going to absorb some of that heat, and then throughout the night keep that room relatively warm.
Exactly. So there's a benefit in cold weather to having your inverters in the same location as your batteries. In hot weather, you do have to keep in mind that, so inverters are a lot less efficient than batteries. So batteries, you're looking at 99% efficiency in a charge and discharge. So you're only generating about 1%. So if you're charging batteries at 1,000 watts, you're only generating 10 watts of heat on a battery. But inverters, you're looking at more like 4% of that energy. So if we're running those heaters in the summertime, that room could get a little bit too hot. And it might be a nice option to have a fan in that room so that you could discharge some of that warm air in the summertime. And they probably do. I haven't looked in detail at this install, but it's a very nice looking install. So this is just an example of showing you how those 5 batteries are really good for large scale systems.
Yeah, it could potentially hundreds of watts of heat being rejected into this room, which can be a bad thing, like you mentioned, or a good thing, depending upon whether it's summer or winter.
Steve put in here to the chat, Daniel, that he does off-grid in Maine. So Steve, send us an email. We'd like to talk to you about that. And I know Daniel is going to be back on the East Coast for some trainings up there, and we'd love to see it. I'm from the East Coast myself. Had a cousin that lived up there in Maine, Portland, Maine. And I'm from northern Pennsylvania, upstate New York. So we see a number of these installs, especially Daniel. You mentioned hunting cabins, etc., where these systems might be off for a month at a time. And so these solutions to have those batteries be able to charge when you're not there, it's important to maintain that temperature.
9 minutes left, everyone. We're getting there. This is we talked Outback earlier. Here's a great picture of an Outback system on a food truck in Oregon. They like their food trucks out in Portland, Oregon. I don't know if anybody's ever done that before. But what I really like about this system is nothing with the batteries, but kind of the way they have these solar panels sliding out on a track here. I do like the way that they've secured the batteries in such a way that if there's some sort of incident or accident with the trailer, that these batteries are going to stay where they were intentionally designed to be. Is an example of some off-grid Arizona systems. And what we're looking at here is I can see a bunch of more Outback equipment. Some of the new radians and a bunch of charge controllers here, all the batteries as well. Look at the way they've insulated this shipping container. And I would imagine there's probably some active heat pumps, maybe some mini splits in there as well.
Daniel, I know we're running low on time. I will say that, you showed an insulated shipping container there. You can get a lot of batteries into shipping containers. We have containerized solutions as well for a high voltage C&I space. And typically these shipping containers can be bought at pretty low prices. I know I was looking at one recently, right, at $3,000 for an insulated shipping container. It can be a very nice outdoor install where you've got some temperature protection.
Yeah.
And so, that is a good point. It's a nice looking install in a shipping container, and you can get that enclosure relatively cheaply.
Yeah, who hasn't wanted to buy a shipping container at some point in their life, right? We do have a lab. We have our research and development facility right next to what you can't see just to the left of this picture is our factory in Oxnard, California, that are putting these batteries together. And one thing, by having this lab, we're able to do a lot of these testings and validation of our systems as well. But we also undergo a number of numerous third-party tests, one of them being the UN 38.3. And this kind of goes back to the question earlier, what state of charge do we ship the batteries? And those regulations have changed a little bit over the time, but one thing that doesn't change is you got to have these listings. And what they do is they being the third-party testing facilities, will subject our batteries to what conditions you might expect to see when it's being transported. For example, if you're going to airship something, what happens in the cargo hold of an aircraft, right? Well, the altitude, the pressure can change significantly, so they simulate that. They also simulate the temperature variations that you might experience as you're going up in the 30,000 feet and coming back down. Vibration of the battery being kind of vibrated, and also they're just shocking it, right? Not necessarily to shock it with electricity, but to drop it and show that you're able to
vibrational shocks. They do drop tests with these batteries, etc.
But they do shock it also with electricity as well, some external short circuits as well, and then overcharging the batteries. And essentially, if your battery doesn't leak, doesn't catch fire, you're able to obtain these certifications, which we have passed, and we're able to airship our batteries as well. Additionally, there's other UL certifications, UL 1642 on the cell level, UL 1973 on the battery module level, and then UL 9540 and 9540A test large-scale fire test. These are very important to a lot of the fire jurisdictions that are really concerned about what we're doing as installers. We're installing energy storage systems that have very dense energy compacted into very small packages, these batteries. And what is that going to look like if during thermal events? So these tests, I'm not going to run you through everything here. We're really proud of our results of our UL tests, and we publish them on our website, just showing that not much happens. In fact, don't go into that unmitigated thermal runaway where cells are spreading to cells and battery modules are spreading to battery modules. What we found is that we spread to one cell and then it kind of puts itself out. Another great example of an insulated battery cabinet here, you can see they kind of put these foam pads in here to cover up the vent holes, and like Nathan alluded to, perhaps they're going to open those up as well. It's great showing how people are running conductors of the same gauge and the same length to a common terminal block, and then running larger conductors to the pieces of equipment as well.
So Daniel,
Yeah.
you just went through all the safety testing that we do.
Pretty quickly too.
And yes, you did. You went through it very quickly, and we do a lot of safety testing, and safety is one of the things that's very important to us. And it's also important to our customers. And when you're installing these on your customer's home, you do want to make sure that you're not installing the cheapest product that's out there, one that might not have gone through this safety testing. Just because you can get away with it doesn't mean that that's what you should do. And I realize that the market is kind of being flooded with these batteries that might not even be what they say on the label, right? And in buying from Briggs and Stratton, buying from these Simplify batteries, you've got a 15-year history of leading the market with safe battery technology. I guess that's one of the things I want to point out to customers as we try to compete with some of these lower cost batteries that are coming in from Asia. It might not be the best choice, even though it might be a cheaper choice.
Yeah, well said. Definitely. And there's an opportunity. The market is growing. There's a lot of people that went solar that didn't have batteries that are now doing that. We're trying to electrify our grid. And there's a lot of subsidies, the new IRA now with 30% tax credit that allows you to take a 30% tax credit, not a deduction, on just doing battery systems alone without having to pair it with solar like we historically had to do as well. A lot of local rebates as well. So always make sure you leverage and know all of those opportunities. Additionally, there's been some changes in the interconnection agreements, especially out here in California, where you can't install solar alone and see a financial return on that investment without pairing it with batteries, because the net metering 3.0 really doesn't allow you to use the grid as your battery anymore. So
you really just don't get that. You don't get the return on investment, as Daniel said, without batteries. Daniel, we've got about 2 minutes left. Do you want to take us through some of those kind of the options that we have for our systems as well? I know you're going to show our ESS system as well.
Yeah, let's keep going as well. Thank you, Nathan, for pushing me along. We do sell generators. Again, Nathan has talked about we're that US-based company. We house our data in the US companies, but we are truly a global company as well. There's the 4.98 battery on the left there. There's our 6 kilowatt inverter. Energy Track control app on the right that allows a lot of functionality and ability to control the systems. So this, again, is the PHY. We talked about that, non-comms, the Amplify comms, and then the Simplify battery that you see there, and then the 6 kilowatt inverter on the right. Again, we want to make sure we understand that we're going to be there for you. It matters who's behind the system, and frankly, it matters what installers are behind the system. So I applaud you for being here today. That shows your commitment to learning and to being a better installer, and that's the exact kind of person we want putting our batteries in as well. If you are interested in generators, we offer those. Our generators can be controlled using 2-wire signal to start from an inverter to start up and stop based on the state of charge of the battery. Not even necessarily need solar to do that. We run them all the way up to larger commercial systems as well. A very aggressive warranty on our generators as well. Let us know if that's something that you're interested in. One thing really when we're selling these systems is to sell systems in packages and try not to confuse the homeowners with different kind of kilowatt hours and watt hours and kilowatts. We did some research and kind of took averages of what a home uses, understanding that most outages for homes aren't as long as people realize. They're usually the nuisance outages where somebody's kind of crashing into the power line down the street. Selling energy storage with the metric of hours of backup really takes a lot of the confusion and guesswork out of your customers' heads. So let us know. We have pamphlets and collateral that we can supply to you that allows you to break down these packages as well. As we're kind of closing out the hour, thank you everyone. I know we just reached the top of the hour. I will encourage anybody who wants to be part of our Elite IQ Installer program. We're going to give you $100 cash back for every battery you sell. Scan that QR code right there. In addition, we'll put you on our maps. You get on a newsletter, and we'll promote your business through social media as well. You don't even have to be part of the IQ program for this, but if you want to be part of it, great. You $1,000 off your first install. This can be either with our inverter or with the Solar converter like you see there on the screen. We already mentioned kind of about the CPUC and the SGIP availability as well. Coming up next week, we're going to be having, Distributech next week, but also replacing lead acid batteries with our Phi batteries. Great opportunity for that Outback system. And then we're going to be doing that off-grid living with Simplified Powers. That's going to be me giving this virtually before we give it live at NABCEP as well. The Power Academy, which is a great online learning tool that we have available. There's the QR code for that. Jump on the Power Academy and look for all those abilities.
And we'll be sending these slides out, right? We'll send these slides out with these links to you after the talk here. We really appreciate your attendance.
Yeah, thank you, everybody. And we're done. Thank you for sticking with us a minute or two over. If you're looking for your NABCEP credits, energy storage training at basco.com, energy storage training at Briggs and Stratton Company.com. That's what BASCO stands for. We have that survey, link to the survey to help us be better right there. Email us your full name, last name, and we'll get you the credits available. Nathan, if anybody needs to jump, go ahead and jump. Nathan, any last comments, questions, or any last thoughts to close us out for the today's session?
Well, Michael did mention that we need to update some of the dates on our form, so I'm going to have to go through and see. Michael, if you're still on, if you don't mind clarifying which form, apologize about that. And then for the rest of you, we just really appreciate you taking the time to be with us, learn with us, and thanks for the questions during the talk. It makes it interactive for us. So if you'd like to help make our trainings better, go ahead and use that survey link. Drop Daniel and I some comments about topics that you would like to see. Michael, thank you for clarifying there. And we'll try to create some new trainings as well that hit the topics that you like. So thanks, guys.
Thank you, everyone. We'll see you next time.